Okay, so regardless of if it was created via renewable technology, that sort of gray area technology, nuclear or hydroelectric, or if it was created using good old fashioned non renewables, fossil fuels, so on, um, ultimately electricity makes it to your house. What do you do with that electricity when it makes it to your house? Well, that's what we're going to be talking about really for the remainder of this module. What do you actually use that electricity for? So, right here, this is a profile of an average American household. This came from the Energy Information Administration. This was as of 2015. Um, but the numbers kind of fluctuate. They don't really fluctuate much from year to year. Well, one of the things that you'll actually find is that the lion's share, the bulk of electricity that we use ends up being for climate control purposes, either space heating, air conditioning, water heating, or for refrigeration. So, more than 50% average household electricity consumption goes towards either heating or cooling. 17% for air conditioning, 15% for space heating, 14% for water heating, and then a smaller fraction, closer to 7%, for refrigeration. That makes, if you actually add all that up, that's actually just a smidgen above 50%. That's 53%. Outside of that, the next big thing is lighting, and then electronic TVs and related stuff. Then drying. So drying of clothes using electric dryers. And then all of these other potpourri of end uses, things such as ceiling fans, air handlers, other auxiliary freezers, so freezers other than your main one, cooking, microwaves, pool pumps, humidifiers, dehumidifiers, dishwashers, clothes washers, hot tub heaters, all those other things, like all are kind of potpourri of things. And then other stuff that's not otherwise classified. So that can include small electronics use. That can include maybe even using your computer. So this is the average household electricity usage. Now, that being said, when we actually talk about electricity usage, about it as a unit of energy. If you ever take a look at a bill, like let's say you live here in the United States and you get an electricity bill, your electricity bill is actually going to give you a statement of how much energy you use. Well, the way that we calculate energy is we take the amount of power and we multiply it by the time. So power times time is energy. And our main that we use is what is called the kilowatt hour. The kilowatt hour. So it is the amount of energy that you use times the time. So power is measured in watts, and then for how long you use it for, that is your unit of energy. So power is given in watts or kilowatts, and then your total energy usage is given in what are called kilowatt hours. So how much power you're using and how long you're using it for. Apply those two things together. So here in most of California, unless you live in Southern California where you are beheld to Southern California Edison, and then there are some regional power companies as well, the bulk of California is actually at the beck and call of PG&E, Pacific Gas and Electricity Company. And the way that PG&E works is they have a tier system for how much they charge you per kilowatt hour. And the tier system is based on what's called a baseline. So every household, depending on the size, depending on the number of people who live in it, depending on the neighborhood, depending on the climate, is given what's called a baseline. And for every household, this baseline is a little bit different. I know that doesn't quite sound equitable, but the idea is that if you are living in a 2-bedroom house in the middle of the desert, you might require more electricity than a 5-bedroom house on the coast. And the reason why is because you're living in the desert, it's really hot. Air conditioning is not really considered a luxury, it's more of a necessity to live there. And so you might need more electricity. And so your baseline might be higher than somebody who lives on the coast, even though their house might be bigger. Well, the idea here is that for PG&E, they charge the lowest amount for tier 1 usage. So if you use up to your baseline, you are charged at the lowest rate. Now, that being said, the more electricity you use, the more electricity they have to generate, which means they're going to pass those costs along to you. So tier 2 electricity generation is anything between 101% and 400% of your baseline. So now this is between 1.01 to 4 times your baseline. And here they charge you really just a few pennies more per kilowatt hour. And then if you use above 400% of your baseline, meaning that you are using a lot of energy, they will actually give you a surcharge. And this is because at this point, you are a burden on the electric grid. If you are using way more electricity than other people in similar households, that is the high use surcharge. And that can be as high as 48, 49 cents a kilowatt hour. So not only are you using electricity, you're paying more per kilowatt hour of electricity. This acts as an incentive to use less, and then it also helps offset the additional money that it costs PG&E to generate that electricity. I don't necessarily feel bad for PG&E in that case, though, but it's kind of a way of punishing those who use too much electricity, which to me, I'm kind of okay with. All right, so the average American household uses approximately 30 kilowatt hours a day. So that's a little bit over a kilowatt hour per an hour. So you're roughly using 1 kilowatt every hour. That's essentially what you use, a little bit more than 1 every hour, or 1 kilowatt hour for every hour. So that's pretty much what you're using nationally. And so this is a residential customer in the United States. So here in the Bay Area in California, and specifically in Santa Clara County, the average is significantly lower. Now, it's not because we're all super eco-friendly, though there is some of that. It's not just because of that, though. One of the biggest reasons why we have a lower energy usage here is that we have climate. Winters don't get really cold here. Like, we're not seeing months and months and months of temperatures in the 20s, teens, and zeros. We're also not seeing months and months and months of hundreds and tens, hundreds and 20s. Like, we're not seeing anything like that here in California, specifically here in Santa Clara County. It might get up into the 80s and 90s in the summertime, and for many people, if you're like me, you hate the heat, you turn on your air conditioner, and that then causes you to use more electricity. But you're a lot less electricity than somebody in, say, Phoenix, Arizona, where they're trying to cool their house from 120 degrees to 80 or to 70 degrees. You're just trying to go from like 85 to 70. So it's really not that big of a difference. And so as a result, you're using a lot less electricity than, say, somebody in Phoenix, Arizona. And then in the wintertime, we don't get those ice cold temperatures that much of the country does. So we don't rely on power as much. We don't rely on electricity as much to get us through that. And so as a result, our daily average is lower. I would also say some of this probably can be attributed to more efficient technologies here in California. A good example of this would be light bulbs. Here in California, we have actually phased out these light bulbs here. These are what are called incandescent bulbs. This is the kind of light bulb, when you think of a light bulb going off in your head, this is the kind of light bulb that you think about. The light bulb that was invented by Thomas Edison, you have a little wire and you get the little coil on the inside really, really hot and it shines and that creates light and everything, and that's how it works. Those are actually very energy inefficient. However, these over here, what are called CFL bulbs, are actually much more energy efficient. These are much more energy efficient. And not only that, these are not nearly as fragile and a lot longer living than incandescent bulbs. So we've actually phased out incandescent bulbs. Most incandescent bulbs require between 40 to 100 watts to work. 40 to 100 watts to work. So when you have a 100-watt bulb on and you use it for an hour, that's 100 watt hours. That's 1/10 of a kilowatt hour. If you leave that light bulb on now for 10 hours, that is a kilowatt hour. If you leave it on for 20, that's 2 kilowatt hours. You leave it on for 24 hours, that's 2.4 kilowatt hours. That right there, just that one light bulb can be 10% of the average, or a little less than 10%, maybe more like 7 to 8% of the average household electricity use. So incandescent light bulbs are energy hogs in a very real sense, especially when you have a light that you may have on the whole time. I'm here recording this at night. I need to have lights on right now. And the good news is the lights that I'm using are CFL. These give you the same level of brightness and the same level of light, and they've even gotten the softness of the light down to a really good one. When these first came out, they felt like fluorescent lights. They're way better now. Well, these use up to 75% less energy and last up to 10 times longer. So one of the things I think many people feel grrr about when they actually go and buy a CFL light, or sorry, yeah, a CFL light bulb, you could get incandescent light bulbs like 2 for like $4. CFL light bulbs are more like 2 for $10. So they're a little bit more expensive, but they only use a quarter of the energy and they last 10 times longer. So guess what? Even though you're paying more up front, which is obviously what we tend to focus on, you're actually saving an ish ton of money in the back, which is good. So this just shows a little bit of a comparison between the standard bulb, the standard incandescent bulb, and CFL bulb. Well, there's very little excuse not to use CFL bulbs. At the end of the day, they may cost more upfront, but they last a lot longer. I've been using these CFL bulbs now for the last 5 years. Haven't had to switch them out yet. That's really awesome. And they use a lot less energy. So it means that even though I'm using 2 lights right now to keep my face illuminated, they're CFL bulbs. So they're using a lot less energy and they're going to last a lot longer. I would laugh if one of these suddenly burnt out right now. Well, the reality is that over the past 10 years, we have actually phased out incandescent bulbs. We didn't necessarily tell people you can't use them anymore. Like, they aren't going to be coming down your door if you still have an incandescent bulb in your house. but we're just simply not letting people make them anymore. So lighting manufacturers cannot make new incandescent bulbs. And instead, an equivalent CFL bulb is sold. And even though it costs a little bit more upfront, it lasts a lot longer, so you're not having to switch out bulbs as much. One bulb lasts the equivalent of 10 incandescent bulbs. That alone saves you money, like a lot of money. And then they're using a lot less energy. So the phasing out of incandescent bulbs, even though it kind of seems like I gotta use one of these new ones, it's actually a really good thing. Now, what about heating and air conditioning? So heating and air conditioning, those are the single biggest energy hogs. The single biggest energy hogs. Here in California, because we have a relatively mild climate, we don't rely on heating and air conditioning nearly as much as somebody in Minneapolis, Minnesota, which gets cold as heck in the summer or in the wintertime, or Phoenix, Arizona, which gets hot as heck in the summertime. We have a nice mild climate here. Even places like Sacramento, which can get pretty hot in the summertime, still not as hot as Phoenix or Los, and definitely not as cold as Minneapolis in the wintertime. So we have a very nice mild climate here. As a result, our energy demands aren't as large. However, there are still things that you can do to reduce your energy demands. One of the big things that you can do is during the summertime, set your thermostat just slightly higher. One thing that a lot of people do that I'm not a big fan of is they tell people, well, turn your thermostat up to 80. Yeah, as a climate alarmist, if somebody tells me to turn my thermostat up to 80, I'm going to tell them to F off. Sorry, I know that that's a little unprofessional, and I'm not going to literally say that to them, but that's what I'm thinking in my mind. I don't handle heat well. I would not work in an 80-degree room. 78, maybe 76, probably 74, definitely. 74, definitely. If I turn off other lights and I open up my blinds and use natural lighting, maybe I can even justify turning it down to 72. In the wintertime, instead of cranking up my heater to 72, that nice, comfortable 72 temperature, instead, maybe I only crank it up to 70. And that keeps us nice and warm in the wintertime. Still plenty comfortable. Still plenty comfortable, but it uses less energy. And if everybody does that, even just a little bit, that adds up, and that can greatly reduce our dependence on electricity, which then means we need to generate less electricity, which means we need to burn less fossil fuels. In addition to that, due to incentives and laws, there are actually incentives for companies to produce more energy efficient appliances, such as Energy Star. Energy Star appliances are much more efficient, meaning they give you the same bang, but they use less energy to do it. So using Energy Star appliances whenever possible is also a really good thing to do here. And once again, these are the biggest causes of energy usage. Even in California, they take up a decent chunk. However, here in California, being more of a conservationist may be as simple as turning off a light. Now, that being said, not all the energy that you use is simply by turning on and off lights, like I just did right there. There's actually other sources of energy that you are also responsible for using, and I'll talk about those in the next video.